You look guilty, Hayden. Why do you look so guilty? So just like y equals mx plus b, where m is what now? M is the slope, and b is the y-intercept. Why is m the slope, by the way? Why not s? Slope starts with s. S does mean something else, but you don't know what it means yet. But why an m? Slope doesn't even have an m in it. Because YOLO. Kind of. It was like a 1600s YOLO. So who invented linear functions? It did not, which would make sense too, but I always love this as you learn math and then you have no idea the history behind it. Take a look at my history math poster back there. On the bottom, the second picture in, do you see a chef with a big pot? And he's got two little pots kind of sitting beside the big pot. And so Carter's back there, maybe he can read. What's the name of the little pots that are lying on the ground? Algebra and geometry, which you started learning back in grade 3, and he dumped those into this big pot, and the big pot is called, which is this unit that you started last year. Who's the mathematician? Well, I'm assuming Carter will tell us that too, since he's back there and can read it. And the short form of his name was René Descartes, very famous French mathematician. He was very sick as a child and spent a lot of time in hospital. And the theory is, we don't actually know if this is true, but the theory is he was lying in his hospital bed looking at the tiled ceiling. And the ceiling was actually tiled with squares, not rectangles like mine. So look down on the ground, because that's actually squares. So imagine you're lying there and you're looking at this. And there was a fly that was crawling across the tiles of the ceiling. And he started to think, if we had some kind of grid that we use numbers, we could always understand the placement of this fly, and we could figure out the distance that he traveled and the slope of the line that he traveled. And that's, in theory, where supposedly he came up with the idea. He was 14 at the time. But he was French, didn't speak English, so the word slope did not exist to him. What is the word for slope in French? It is pente. And pente also means the same in English, slope of a mountain. And what does mountain start with? And in French, what does to go up a mountain mean? To go up something is monter, and that's where he got the M from, was the word for monter. Completely irrelevant, but kind of cool. That's why it's an M. Yeah. Most people name it after themselves, but yeah, he wasn't that arrogant. I don't know. Although Descartes, distance, he might have picked that. I don't know. And if you think in French, what's the French name for a map? Carte, that's where it comes from. It's from him. And if you think of the Cartesian plane, that's the XY grid, Cartesian comes from Descartes, all named after him. Absolutely, yeah. Most mathematicians at the time were very much into physics and astronomy, but they were also into religion and world politics. Mathematicians were like the smartest people in the town, so they were like, let's elect them, because clearly they know what they're doing. So lots of mathematicians were politicians. They also were mostly in psych wards as well, because there's a fine line between genius and insane. And a lot of mathematicians, when people were like, that's crazy talk, they'd put them in asylums till they figured out, oh, wait, no, they're right. Sorry about that. Pythagoras, if you weren't with me in grade 10, you never heard the story, but Pythagoras at the time, people thought he was crazy. Like a squared plus b squared equals c squared. Total crazy nut job. So they exiled him from his town. So he was like, well, screw you, town people. I'm going to make my own school. So he invented a school and got all these little people to come and be at his school, and they all wore white robes, because that was like the dress at the time. And what do we call it now when a bunch of people who maybe have crazy ideas get together and live together? It's a cult, and that's what they called it back then, was the cult. And so they took Pythagoras, was like, no, you're not starting a cult, and they decided to kill him. And way back in 3000 BC when he lived, what was the most common way of killing people? How by execution? Not beheading, that came in the 1400s. Hanging came in the 1200s, burning was about the 1100s, stoning. Which, if you don't know what stoning is, it's not just, they poke pebbles at you until you die. No, they bury you up to your neck. So the only thing sticking out of the ground is your head, which means you can't block the rocks because you don't have hands. Then they don't use pebbles. They use small boulders, and they throw them at you until you bleed to death. Very painful, very excruciating. And then 1,000 years later, we were like, oops, Pythagoras, you were right. Sorry, now let's teach this to children every year in school. Sorry about that. We kind of killed you there. That was totally off topic, but there's the story of Pythagoras. Most mathematicians at some point in their career were in some kind of insane asylum. Kind of cool. But back to quadratic functions. So m, b, remember m represents something and b represents something. Same thing with this. Our a and our q and our p are all going to represent something, and they're going to do something different to the graph. What does m do to the graph? Yes, it means slope, but what does slope mean for a graph? Yeah, it's the incline. So the bigger the slope, the steeper it is. The smaller the slope, the flatter it is. What does b do to the graph? It's the y-intercept, so it's moving it up or down the y-axis. All of these guys have things too. Let's start with A. The number out front affects the width of the graph. If the A value is greater than 1, so any number that's bigger than 1, you end up with a really skinny parabola. If the A value is bigger than 1, you end up with a really skinny parabola. If the A value is between 0 and 1, so watch the notation here, 0 less than A less than 1. And just if you've forgotten, this less than, a variable less than, is an English word. What word is that? So what am I saying here? It's the word between. So it's saying if A is between 0 and 1, so it's 0.9, it's a quarter, it's 3/5, it's 0.0001. You end up with a really wide parabola. And you don't actually need to know the y until next year, but I like to show you now, especially for tactile people. So get up. Get up. Tactile people need to move. Oh my God, she's making us get up. This is terrible. My grade 9's last class sighed because I let them do their homework in class. Like, what is going on with you people? So I want you to become a parabola. Using your arms, show me a very nice parabolic shape. So it's got curve to it. It's not like straight lines like robot, right? It's got a very nice curve to it. Now I want you to put your feet on the ground, shoulder width apart, and I don't want you to move them. So you are what's called rooted. You're rooted into the ground. If you've done yoga, that's the first principle of yoga, is rooting yourself. And what this A value actually is, and again, you don't need to know this till next year, the A is called a vertical stretch or compression, and this is going to come back in a big unit in grade 12. And I want you to imagine your parabola is being grabbed by two giants. One is grabbing the left-hand side and one is grabbing the right-hand side, and they are yanking as hard as they can on your parabola. Now, you're rooted to the floor, so you're not going to come off the floor, but what's going to happen to your parabola if I stretch it vertically? So giant pulls, 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 pulls. What's going to happen? Look at the shape of your parabola. What happened to it? That's why when A is bigger than 1, it's going skinny. It's called a vertical stretch. We're not done. Go back to your parabola. Now what's going to happen is these giants are going to come and sit on the edge of your parabola. One's going to sit on the left, one's going to sit on the right. So if something comes really heavy and sits on your parabola, what's going to happen? Right, it's going to squish out sideways. That's called a vertical compression. So vertical compression is when the number's between 0 and 1, and that's why you end up with a wider parabola. You don't need to know any of that, but that's why that's happening. Skinnier and wider, remember that for next year. So if A is bigger than 1, skinny. If it's between 0 and 1, flat and wide. What numbers have we not talked about yet? Negative. So if A is less than 0, what is upside down? Oh, I thought you meant I had written it upside down. Like, I'm not that good. I can write that upside down. That's when you get a down-facing parabola. So anytime there's a negative in front, that's what forces it to go down. You don't need to know this either, but next year they're going to tell you what's happening there. It's called a vertical reflection. Do you remember reflections back from grade 9? It's where you take an object and you flip it over something. So what we're doing is taking an up parabola and flipping it over the y-axis. And when you take something pointing up and flip it, what happens? Points down. That's why.
So if A is below -1, it'll be narrow, and between -1 and 0, it'll be
If it was 0 exactly, what would happen is this: you would have no x squared, and if you have no x squared, it would be linear. So it can't be 0 and still be a parabola. This is no effect on vertex. So just because you yank it or you squish it down or you flip it, you're not changing the vertex. It's still going to be the same. If the vertex doesn't change, what else doesn't change? Axis of symmetry. Axis of symmetry. What else doesn't change? X-intercepts. It depends where it is, but generally not. Will it affect the max-min? It doesn't affect the value, but what does it affect if we're going from up to down? It's going to affect whether it's a max to a min, so a min might go into a max. That doesn't make sense now. Let's put the second bullet there. If a min becomes a max or vice versa, what other one of those 8 components is going to change? Yeah, so then what does that affect? There's another one we talked about. So go through that list from yesterday. Actually, it's down here if you want to peek. The range is going to change because of this. Remember, the domain's the one that never, ever, ever changes till next year. So just like M is slope, and that changes the incline of the line, this is called, and you don't need to know this word, but it's called a vertical stretch or compression. It affects the width and the direction. Because the width and the direction change, these things down here might change. P is the number inside brackets as opposed to Q, which is the number outside of brackets. So I'm going to call this one inside, and I'm going to call this one outside. Some textbooks use P and Q. Some textbooks use H and K. It doesn't matter what you use for them. They're still going to do the exact same thing, so it just depends what book you're using. The number inside the brackets is what's called a horizontal translation. Horizontal translation. And you did translations, again, way back in grade 9. So you did reflections where you flip something. You did rotations where you spin something. What were translations? They're the movements. So this is a side-to-side movement. You're either moving it left or moving it right, depending on the value. If P is a positive number, so if P is greater than 0, it's a movement to the left, which I know makes no sense because on the x-axis, the positives are to the right. It's just the way it works. Don't argue. If P is less than 0, meaning it's a negative number, it's a movement to the right. Well, the minute I start shifting stuff side to side, what am I going to affect for my parabola? The vertex, and because the vertex changes, what else is going to change? The axis of symmetry, potentially the max-min, potentially the range, potentially the y-intercept, the x-intercept. What's not going to change? The domain, because it never ever changes, and the direction. This will not affect your direction. So everything changes, or has the potential to change. Except domain and the width. Except. I put expect, didn't I? Except. See, I be not your English teacher. Which my other class said it was halves with an F. And that didn't seem right, but I said that too, but they argued, so I let them write it down. They also wondered why James had a briefcase. I said I couldn't tell them or I'd have to kill them. Q, again, some textbooks will call this K. Don't get too caught up in the letter. This is the number that's outside the brackets. This is what's called a vertical translation. Instead of moving things left or right, take a guess. Up and down. If Q is greater than 0, meaning it's positive, it goes up. If Q is less than 0, meaning it's negative, it goes down. And if we start moving something up and down, what are we potentially changing? The vertex, which means the axis of symmetry, which means the max min, which means the range. What are the only things that won't change? That won't change, correct. You're right, because that won't affect the correct. So axis of symmetry, what else? Domain. And width. Did I get it? Yep, except I got it this time. Axis of symmetry. Domain. Width. That's the theory you need to know. What you really need to be able to do is now look at a question like this without the graph and do exactly what we did yesterday. So we're just taking it one step further. Now we don't have the picture. We're going to be able to determine all of these 8 things just from the equation. Grab a piece of paper. Write the title on it if you haven't done that already. Thank you for no one saying, we need paper. I don't know why I had to go vertically. I just had to go vertically. I don't know. So the first couple examples, I'm just going to pick apart these numbers and just show you what they mean. Generally, I don't do that. I would go straight to this, but I just want to show you step by step. This negative out front, what that tells you is the direction is going to be flipped down for this parabola. It went from pointing up to pointing down just because of that negative that's in front. The 2 affects the width. Does a whole number make it skinny or does it make it wide? Are you stretching this or are you compressing this? It's stretched. So what it means is it's now pointing down and it's going to be skinny. That's what the 2 is telling you. It's going to be a skinny parabola because you have stretched it. The 3 is a horizontal translation, which means you're moving to the left or right. The value tells you whether it's left or right. If it's positive, it is going to the left. If it is negative, it is going to the right. So this parabola has gone 3 units to the left. The 8 is a vertical translation, meaning up or down. The value tells you what's direction. If it's positive, it has gone up. If it's negative, it has gone down. So this parabola has gone 8 units down. Why down? Because it's negative. Sorry, for this one? Positive goes to the left, negative goes to the right. It's very counterintuitive to what you think it should be. Yeah, the horizontal one's a little bit funny, and you'll learn why next year. So if I took away all these numbers and I just looked at the base graph of y equals x squared, what it tells me is the vertex is right on the origin. It's got what's called a standard width, standard direction. So it looks like a normal parabola, something like this. What I have done to it is all of these numbers. I have flipped it over, I have made it skinny, I've pushed it to the left 3 units, and I've pushed it down 8. So the vertex would have been 0, 0. Which of these now is going to change the vertex? Is me flipping it going to change the vertex? No. Is me making it skinny going to change the vertex? Is it me pushing it to the left going to change the vertex? Yes. 0, 0 if for this 3 is going to become now negative 3, 0. What about pushing it down 8? Yes. So you can get the vertex just by looking at the equation by doing the following. Take the number in brackets, change the sign. Take the numbers at the end, leave it alone. Take the number in the brackets, change the sign. Take the number at the end, leave it alone. So the vertex has to be the number in brackets, change the sign, negative 3. The number at the end, leave it alone, negative 8. Little picture is just to show you in theory what's happening. This has moved over 3, down 8, and now it's down and it's super skinny. And later on in the unit, we'll see exactly how to get the graph. This is just a sketch for the visual people. That's what we've done to our parabola. I'm going to repeat if you're a word person. Take the number in brackets. Take the number in brackets and change the sign. Take the number at the end or outside brackets. Take the number outside brackets. Leave it alone. I'm going to say that probably half a bajillion times between now and the end of the semester. Take the number in brackets, change the sign. Take the number outside or at the end or outside the brackets, leave it alone. Once we have the vertex, we've really got almost all the other stuff. Do I have the axis of symmetry? Yep. How do I present the answer? X equals, and I grab the x coordinate from the vertex, -3. I always go to direction because the direction tells the max min, so I always jump to D. The direction comes from the very front. If there's a negative, it's down. If there's no negative, it is up. This one has a negative, so the direction is down. I use the little picture to determine max min. That's why I do direction first. If it's a down pointing parabola, do we have a maximum value or a minimum value? We have a maximum value. And how do I present the answer? Y equals -8. Domain is the idiot point. It's never going to change till next year. Pick whatever one you like, either XER or -infinity to infinity. Which one do you guys prefer? XER. The range, I go back and I get it from the picture. The smallest value, because of the arrows pointing down, I know is going to be -infinity. And the highest value has to be my max from up to -8. Whichever way you write it doesn't matter. You just need to match what you had here. How do I give in this notation all of these values from -infinity to -8? Y is less than or equal to -8. Correct. Y-intercept, we have to do a little bit of work. How did you find y-intercepts last year? So if I gave you something in standard form and said, what's the y-intercept? So it's something with b, but let's pretend it's in standard form and you didn't know what b was. How do you find any kind of intercept, whether it's x or y? Put 0 for the other variable and solve. Exactly the same thing here. Set x equal to 0 and solve. What's going to happen where you're going to make your mistake is if I gave you this linear function. How do you know that's linear, by the way? Highest degree is 1. And I said, what's the y-intercept? 5, right? Everyone know it's 5 because I put a 0 here. I get 4 times 0, it's 5. If I gave you this line, and I gave you 2 seconds, tell me what's the y-intercept? How do you know it's 1 just by looking at it? Because it's always this number at the back. The problem is that's not going to work with a parabola. If I give you this, and I can't remember what the question was, I'm just making it up. You can't assume that this is the y-intercept. It doesn't work that way. Because you'll see in a second we have to put a 0 here, but this isn't going to end up being 0. Because it's going to be 0 plus 3, which is, and then we're going to have to square it, which is, and then we're going to have times by 2, which is, and then we're going to have to combine it with that, which is not -8. So a really common mistake is people are just going to look at a parabola and grab that last number and say it's the y-intercept, but it doesn't work that way. You have to do bed mass first. So going back to the original question, I'm keeping the y. I'm keeping the -2. I'm taking out x. I'm putting in 0, keeping everything else exactly the way it is. Bed mass, what do we do first? Okay, 0 plus 3. After brackets, okay, so 3 squared. After exponent, multiplication, so I need to do this first multiplication. -2 times 9. And the very last step? Combine them, subtraction, addition, whatever you want to call it in your head. Put those two together, negative 26. Was there any way to look at this equation and know it would be negative 26? So again, you might want to make yourself a note. Don't grab the last number for y-intercept. It doesn't work that way with a parabola. Don't grab the last number. How do I present the answer for a y-intercept? Zero, comma, negative 26. Okay, what about x-intercepts? Set y equal to 0 and solve. Okay, so the last two, the y and x-intercepts, is exactly how you did them for lines. There's just a little bit more work than there was last year. So putting a 0 on the left, then I've got my negative 2, x plus 3 squared, minus 8. Oh my God, it's quadratic. How do we solve a quadratic? Well, there are 4 methods. What are the 4 methods to solve a quadratic? Give me the 4 methods. This is why we did Unit 3. It all comes down to defining the x-intercepts of a parabola. This is the whole purpose of Unit 3. Unit 3. That's the only reason, because we have to solve a quadratic. That's it. Okay, now be smart. We already have a binomial squared, so which method is going to be the easiest here? Square root method's going to be the easiest. You can use quad formula, but then you got to FOIL this binomial. You got to multiply everything by negative 2. Then you got to add in the negative 8. Don't do that work. You could do factoring, but you're going to have to do the same thing. You're going to have to FOIL it all out, get it all into factored form. So do this method, which is the easiest. Good time to review, since there might be a test coming up on this. What's the first step on square root method? Isolate the squared part. So I want to get the 8 over to this side. What happens to negative 8 when I take them over? I'm hearing kind of some mumbling, but no clear direction. And this is now when either people just bolt from the question and don't finish it, or they just pretend that that little negative didn't happen to be there, and it clearly must be 2. Can you square root a negative? No. No. So if you can't square root a negative, what does this mean? No. There's no solution. What does it mean in terms of what's going on in this parabola? There's no, we'll take a look at the graph up here. Why does it make sense that there's no x-intercepts? Because it doesn't cross, so there are none. What? Unit 3 ties into Unit 4? That's crazy talk. Crazy. If you have good logic, yes. But if you don't practice the skill, when you get to cubics and quartics and quintics, you're going to be crying. Next year. Now I'm going to go sideways just to bother the lefties. I'm trying. Does it bother you that there's not an even amount to make that in? No, we do things multiple ways. When we don't have the graph, you take the number inside brackets, you change the sign. You take the number outside the brackets, leave it alone. Take the number inside brackets, change the sign. Take the number outside brackets, leave it alone. I don't have brackets. Well, there's a number inside those brackets. We just don't see it. What are we adding to the x that we wouldn't see? 0. So this means the vertex is 0, comma, 2. So if there are no brackets, it's just 0. If there's no number here, imagine that 2 wasn't there. What would I put for the second coordinate? 0. Don't overthink it. If there's nothing there, nothing means 0. Write down the axis of symmetry. I always go to direction first because I'm visual and I like the picture in order to get this over here. Doesn't matter the order you do them. Up or down, 50-50 shot. How do we know it's down? What tells us in this that it's pointing down? The negative out front. If there's a negative out front, it's pointing down. If there's no negative, it's pointing up. Because it's pointing down, do I have a max or a min? What's the value of the max? How do I present the answer? E is the domain, freebie point. Everyone should get this. If you don't get the domain, I will hurt you because you just need to memorize XER. Mm-hmm. I'll be waiting outside behind the school. F, the range, this always takes a little bit of thinking. I go back to the picture. Because it's pointing down, I know negative infinity is the bottom. What's my max going to be? It's got to be 2. So how do I say all the numbers from negative infinity to 2? Oh, positive 2. G and H are the ones you need to do a little bit of work. BEDMAS, what do I do first? Brackets don't have any. Exponent, 0 squared. Negative times 0. What's the y-intercept? So sometimes you can grab the last number, but I don't want you to think that and then always grab the last number. So it really matters if you've got brackets and you've got numbers. Just do the work every time because it's going to help you later when you do quartics and quintics and cubics. How do I present the answer for y-intercept? How many methods are there to solve a quadratic? Which method would you like to use? Dead silence. What's always the easiest in this form? Square root's going to be the easiest. If you want to use another one, you use the other one. It's going to be the easiest. How do I get rid of a plus 2? Oop. How do I get rid of that negative in front of my x squared that's kind of into my equal sign here? How do I get rid of the negative? Divide by negative 1. Ooh. Why is that plus or minus so important here? And how many x-intercepts are there? If I forgot the negative, I'm going to think there's 1, and there's not, there's 2. So what are the 2 numbers? Square root of 2 comma 0 and negative square root of 2 comma 0. Questions so far? Well, the problem is if you want to do decimals, suddenly it becomes a calculator question. And this generally would not be calculator. So if you have your calculator, great, give the decimal. If you don't, there's no point. 1.17, totally making that up out of my head. I don't know. Mm-hmm. What was it? 1.41, there we go. Was that a goat noise? Was there a goat involved there? Just to mess with you. Because this side of the desk is way more fun than that side of the desk. I get paid on this side. Suckers. Vertex first. Take the number in brackets, change the sign. Take the number outside the brackets, leave it alone. You kind of stole my thunder there, 1 comma 2. What about this half? Doesn't affect the vertex. What's the only thing this half affects? The width affects none of these at all. So that half in terms of these 8 criteria, irrelevant, doesn't matter to us. It's going to matter when we graph it, but that will come later on. Write down, don't say it, write down the axis of symmetry. Peek over someone's shoulder, not in a creepy way. Compare, a little high five if you have the same axis of symmetry. Thank you. What would you like me to write down? Write down the direction. I always go to direction. I just have to do it next. It's D. Write down the direction. How do you know the direction? It's the very, very front, and it's just if it's positive or negative. If there's no negative, that means it's positive. If it's positive, it is up. Write down the max or min and its value. Joe, what's the matter? You have a look of, Max or min? Value. If I forget that y equals, what's going to happen? Yeah, you're going to lose a half mark if you forget the y equals, so don't do that, because if you forget it all the way along, then that's just nasty. Domain, write down the domain. Then you compare, and if they do not have the domain written down, you smack them right in the middle of the forehead, but lovingly, not meanly.
Oh, look at that. You don't have it written down.
Just in case somebody likes it, what's the other way to write the domain? So one of these, your choice. Again, I go back to the picture to get the range. Because the arrows are pointing up, I know the top value is infinity. Because I have a min, I know that the bottom is 2. How do I say all the values from 2 to infinity? Let's just pretend you like the other notation. So let's do it from here. What's the lowest value? What's the highest value? What kind of bracket does 2 get? What kind of bracket does infinity get? If on a quiz, a test, the exam, you gave me that as the answer, you are getting both of them wrong. Both of them, because they're both incorrect with each other. So you can't mix and match. You're either giving these 2 or you're giving those 2, but not the other one. Y-intercept. Well, y-intercept must be 2 because it's at the back all by itself. No, that'd be lovely if it was, but it can't. We got to do a little bit of work. How do we calculate a y-intercept? X equal to 0, then do some BEDMAS. What comes first with BEDMAS? 0 minus 1. What comes next with BEDMAS? Exponent, negative 1 squared. What comes next with BEDMAS? Multiplication, a half times 1. What comes last? Addition, a half plus 2, 2 and a half. If you'd rather give an improper fraction, you could write this as 5 halves. Totally up to you, I don't care. Could you have looked at this and guessed that it was 2 and a half was a y-intercept? Maybe if you could do some BEDMAS in your head, generally not. So don't think it's the last number. That only works with lines. How do I present the answer for a y-intercept? 0, comma, whatever, yeah, I like it. X-intercepts. Now, common mistake, people put 0, meaning there are 0 x-intercepts. But is that a great way to express that? Because if you put 0, I'm like, is that the value 0? Is that 0, 0? I don't know what that means. You can put none. You can put NA. You can put there are none. Don't leave it blank. Blank means you don't have a clue what to do. I would write the word none. Put a sad face. I don't care. That helps. Just don't put 0 and don't leave it blank. Questions? Mickey sheet from yesterday. Flipped over.